It worked. Okay. Yeah.
No, he meant to help you.
All right. So, all right, guys, it needs to be quiet. It needs to be totally quiet and totally focused right now, because I kind of went over on the boards. I should have stopped a few minutes earlier. Exponent rules. First of all, we're just going to remember what we already know, okay? And then I'm going to add one more rule, which the homework is all about. And so you just have to really know that new rule. But first of all, the rules we know. We know that if you have x to the m times x to the n, I have the same bases, right? And they have exponents, and I'm multiplying, then my final answer will be the same base with the addition of those two, m plus n. So examples of that would be x squared times x to the fourth is equal to x to the 2 plus 4, which is x to the 6th.
Yeah, it's pretty.
Okay? It's not hard. When you're multiplying same bases, the x is your base, same bases with exponents. When you multiply the bases with exponents, you add the exponents, right? This is a shortcut. It's an algebraic shortcut.
2x times 4x equals
Okay.
that many
So,
x.
okay, right. Did you have a question first, though?
So when you're doing the problem, do you always have to do like the first equals, like when you have the problem, then you.
Do I have to do that step? You don't have to do this step. I do this so that you see what I'm doing.
Okay.
When I do it, I don't usually do this. I usually jump straight to this. That's fine, right? All right. Another one. X to the 8th times x to the negative 4 is equal to x to the 8 plus a negative 4, or 8 minus 4, right? You just an 8 and a minus 4, so that gives you x to the positive 4. Okay? All right. What if I put coefficients in front of them? If I say 2x to the 4th times 3x to the 5th. Okay. There is the
don't you like
commutative property of multiplication. Remember that? That they can commute, they can move. So that I could do 2 times 3 first, which is 6. And then I can do x to the 4th times x to the 5th, which is x to the 4 plus 5, which is x to the 9. Yes.
So if you had, if suddenly there was magically a y in that, it was like, if that x was a y,
If
one of the y's, if one of the x's were y's, then could you still multiply?
This is an important question.
Then do you still multiply the coefficients together?
Yes.
And have something x?
So Dee Dee's question is this. That's a great question. If you have 2x to the 4th times 3y to the 5th, okay, I would still multiply the 2 times 3 together, which is 6. But what about, do I have same bases?
No.
No. If I don't have same bases, I can't combine them. So I'm just going to have to write x to the 4th, y to the 5th, and I'm done.
Okay.
But I did have to multiply those coefficients, right? Make sense?
And
Okay.
There's no
6x to the 4th
symbol,
y
you
is the
just
same as
assume
putting
multiplication.
And if there's no symbol, you assume multiplication. With the one exception of, like, if it's a number and it's 13, you wouldn't assume that's 3 because it's 1 times 3, right? It's with a number itself, you keep it as a number, but with variables next to them or numbers next to variables, yes. Okay, so that was our first rule. I'll leave that up. Our second rule was x to the m divided by x to the n is equal to the same bases, so it's the base, and then when you divide same bases with exponents, you subtract the exponents. So you do the top, you go top down. So m minus, this is like a huge minus sign, n, right? So an example of this would be x to the 8th over x to the 5th is equal to x to the 8 minus 5, which is equal to x to the 3rd. Right? You guys remember all these?
Yeah.
And if I gave you a harder one, right, that looked like this, what if I gave you 8x to the 4th over 12x squared. I would separate them. I would first think of this as a fraction, 8/12, and I would simplify that. 4 goes into both of those. 4 goes into 8 twice. 4 goes into 12 3 times. You with me? So I write my fraction right now, 2/3. And then I have my rule. I've got an exponent, and I'm dividing them, so I'm going to subtract x to the 4 minus 2, or
2/3 x squared.
right, 2/3 x
Can you
squared.
put X on the top?
You could also put the x squared on top, so you could say 2x squared over 3, which is actually what I usually do. But I'm finding that it's easier to teach it this way, and then understand that if it's not a fraction, the x squared would actually would belong in a numerator, right? Because it would be x squared over 1, right? You all get that, right? Okay. So, all right. So those, just to 5, you got those, right? Makes sense. Okay. So I wish I had more time. Doggone it. Can I erase all this?
I'll erase all.
I don't know how it is that I think I've got it just right, and then suddenly it's 5 to 10 minutes later than it's supposed to be when I start. All right, we're going to talk about negative exponents.
Ooh.
God.
Because up to this point, you have been leaving them the way they are. And I have told you that that's going to change, and now it's going to change. All right, a negative exponent. If there's a rule that says x to the negative m is equal to 1 over x to the positive m. That's interesting.
Wait, we've been doing that?
So I'm going to show you an example. So if I have x to the negative 4th, there's a rule that says, this is the rule, never leave your final answer, never leave your final answer, this all on her, final answer with a negative exponent. Okay? Never, never, never. Therefore, if you've got an answer of x to the negative 4, you would have to basically, this is really technically what you're doing. Think of the x to the negative 4 as a fraction. Let's create it as a fraction, right? You with me? You guys see that?
Yeah.
I put it over 1. All you have to do, this is key, if everybody's paying attention, you'll totally get this. All you have to do to change a negative exponent into a positive is move it across the fraction line. So what is the hidden coefficient in front of this x?
1.
That 1 is going to stay up there. The only thing that has the negative exponent is the x, not the 1. Right? So suddenly the 1 stays upstairs, this goes downstairs and now becomes positive 4. X to the positive 4. That's a really awesome little trick. To change any negative exponent into a positive exponent, you flip it to the other side of the fraction line.
That's cool.
That's all you have to do, and then suddenly it's positive.
So if you have
So-
2x to the negative 6, it would be 2x over 2
So
to x over
let's just do a bunch of examples. So this was example number 1. Let's do example number 2. Let's say I had 2x to the negative 6. 2x to the negative 6. I am going to put it over 1, and only the thing that the negative 6 affects, which is the x to the negative 6. Does it affect the 2?
No.
No, it's not next to the 2. The negative 6 is only next to the x. So the 2 stays upstairs, but the x to the negative 6 goes downstairs and becomes x to the positive 6. Okay? You with me?
Mm-hmm.
All right, question, yes.
Okay, but if you had parentheses around the 2 and the x, but the -6 is outside the parentheses, so the -6 is affecting
Yes.
everything. in the
I'm gonna
parentheses.
teach that one in a little while, but not today. But it's a good question.
And
So 3, another example.
do we have
Let's say I gave you this, x to the 3rd times x to the -8. What would that give you? X to the
Third.
3 minus 8, which is -5, right? Now, it used to be that that's how you answered the question, right? You guys with
You
me?
have 1 over x to
So
the
now it's going to
-5.
be 1 over x to the +5. We're going to talk about this again tomorrow
Yeah.
in more detail. Yes.
For number 2, you did 2 times 1, right? You multiply them together, or you just
Yeah. In this case, your coefficient is the 2,
Okay.
right? And so I just leave the 2 up there, and I just move this one down.
And then on the homework, did you put the 1 under the 2x minus 6? But you wanted to do that because for number 3, we just have the answer x to the -5th. You first put a 1 over it and then make it.
Oh, I was just showing you that you don't have to. I mean, once you understand it, you can go from here to here, no problem. Okay? So let's just do a few like that. Let's just so that we're good at them. How about x squared times x to the -10? That would be x to the -8, right? 2 minus 10 is -8, right?
Mhm.
With me? So what's the final answer? 1 over x to the +8. You're starting to see it? And I'm actually going to explain why tomorrow. I just don't have the time today. I should have started later. Fist to 5. Do you guys see this? Is it making sense to you? All right. Now, I think that's all I have. I don't think. Now, what if I gave you something like this? I don't know if you'll be able to do the homework or not. I mean, all of
Wait,
it.
why
but
does x? Oh wait, never mind. Sorry.
I will explain why this is the case tomorrow, but I don't have the time today. That's why I'm not doing it. But what was I going to do? Oh yeah. What if I gave you this? What if I gave you this? X squared y to the -3. What would you do? Bella, what would you do?
You just have x.
Put it over
to-
1 for a
That's
second, right? Let's put it over 1 for a second because that makes it easier. Now we have a fraction.
Wait,
What do we want to
You
change?
just have x over 2. X to the x squared over y to the 3rd.
Y to the 3rd. That's the only thing that goes downstairs, right? Do you see
Oh,
that?
because it's negative.
Yeah, but as soon as you bring it down across the fraction line, sorry, that becomes a positive exponent. That always changes the exponent, all right?
Oh my god.
What if I did this? What if I said x to the -4 over y to the -6? What would I have to do? I've got both of them are negative exponents.
And there are
So this one has to go across the fraction line down here, right?
so you just have
And then you.
But this one has to go across the fraction line upstairs. So suddenly I've got y to the +6 over x to the +4. You with me? That makes sense?
Yeah.
Or that was number 6. Let's do number 7. Let's say I gave you something horrible. Like,
Scary.
let's say I gave you this. 2, let's do A. A to the -4, B squared, C to the -8, all over 3
It's ABC.
to the -1.
Oh my god.
E to the 5th.
Wait.
All right.
wait, That's not mean, Gary. That's mean.
All right. So 2/3. Can I simplify 2/3?
No.
No, I can't in this case, so that's okay. But what do I need to do? I know this has to go downstairs, right?
It
This
goes
has to go
down.
downstairs. this has to go upstairs, right? You see what I'm doing? Does that all make sense to you? Anything with a negative exponent has to be swapped to the other side of the line. So I'm going to have 2, and what I'm going to do is I'm going to do 2/3. I'm going to draw a long fraction line. All right? And I know my a to the -4 is going to go downstairs, so I'll put a to the +4 here. I know my d to the -1 is going to go upstairs. D to the +1, or D.
to the +1.
B squared, can I just leave that?
Yes.
C to the -8.
Goes downstairs.
C to the +8 down here. And then E to the 5th. You with me?
You're basically making
Makes
everything
sense?
positive.
Right.
And it's not very nice.
All right, 8. Last one. What if I gave you this?
Yeah.
What if I gave you this? X to the 5th
Actually.
over X to the 9th.
Remarkable thing.
What would that be? How would I simplify that?
You don't.
You don't. It's
You
good.
wouldn't.
It's half.
Oh, wait,
They're
yes,
same
you do.
basis. They're
Wait,
same
you do.
basis.
Oh, wait.
Oh,
So,
you make it
so you get 5. So x times -4. I mean x.
-4.
Sorry, x to the
Which is X to the
-4,
-4.
and then you just flip it.
one.
Which
You
is
do that stuff.
1 over x to the 4th.
1 over X to the 4th, right?
1 over x to the 4th.
1 over X to the 4th. All right, so I think that's all you need to know to do the homework. I could be wrong, but I'm pretty sure. But if you get confused, feel free to look at the video again tonight, okay? It takes a little getting used to this particular rule. A lot of you will forget to switch it,
I picked on my homework.
All right, that's it.